Hey, so we're going to pick up where we last left off. We are in the IBM Data Analyst Professional Certificate Program, and within that, we are on course 4, which is Python for Data Science, AI, and Development. And in that, we are on week 5, and specifically on the GDP data extraction and processing lab. So there we go. We're going to start with that. And continue where we left off. Alright, so in this lab we are essentially gonna learn about APIs, and APIs lets two pieces of software talk to each other, just like a function. We don't have to know how the API works, but only its inputs and outputs. An essential type of API is a REST API that allows you to access resources via the internet. In this lab, we will review the Pandas library in context of an API. We will also review a basic REST API. So, Pandas and API. Pandas is actually a set of software components, much of which is not even written in Python. So we are going to start with importing Python and importing matplotlib, out of which we are going to take the pyplot library and use that as PLT. So you're gonna use matplotlib to plot stuff and create images and visualizations. We create a dictionary, which is just some type of data. When you create a pandas object with the data frame constructor, in API lingo, this is an instance. The data in the dictionary is also passed along to the Pandas API. You then use the data frame to communicate with the API. So in this data frame, we're going to take this dictionary, pass it to a Pandas object with the data frame constructor, right? So we are essentially passing this dictionary into this data frame object, or rather the data frame constructor for the pandas object, and then we're going to find out the type of our data frame now. So it's a core data frame. So our Python program, the pandas object, other software component, data. So when we call the method head, the data frame communicates with the API displaying the first few rows of the data frame. So when we run df.head method, we get the top 5 rows of the particular table or the data frame. When you call the method mean, the API will calculate the mean and return the value. So let's run this, and we got the mean. So mean for A and B. REST APIs function by sending a request. The request is communicated via HTTP message. The HTTP message usually contains a JSON file. This contains instructions for what operation we would like the service or resource to perform. In a similar manner, API returns a response via an HTTP message. This response is originally contained within a JSON. In this lab, we will use the NBA API to determine how well the Golden State Warriors performed against the Toronto Raptors. We'll use the API to determine the number of points the Golden State Warriors won or lost by for each game. So if the value is 3, the Golden State Warriors won by 3 points. Similarly, if the Golden State Similarly, if the Golden State Warriors lost by 2 points, the results will be -2. The API will handle a lot of the details, such as endpoints and authentication. It's quite simple to use the NBA API to make a request for a specific team. We don't require a JSON. All we require is an ID. This information is stored locally in the API. So let's start by importing the module teams. So let's do pip install NBA API. So we are right now installing the NBA API on our Jupyter Notebook, which is done. So from NBA API.stats.statistic or stats.static, import teams, and we'll also import matplotlib. So here we're defining a function one_dict where we are passing the parameters list_dict, where the keys are iterated over list each item in the list dict with the key for that particular element or that particular order in the list. So outdict is key for key in keys, for dict in list dict, for key value in dict dot items, out dict dot key, append value, return out_dict. Method get teams gets the list of dictionaries, and we're gonna use teams.get teams to get the list of dictionaries related to NBA teams and store it in the variable NBA teams. The dictionary ID has a unique identifier for each item as a value. Let's look at the first three elements of the list. So you have the Atlanta Hawks, the Boston Celtics, the Cleveland Cavaliers. To make things easier, we can convert the dictionary to a table. First, we use the function onedict to create a dictionary. We use the common keys for each item as for each team as the keys. We use the common keys for each team as the keys. The value is a list. Each element of the list corresponds to the values for each team. We then convert the dictionary to a data frame. Each row contains the information for a different team. So NBA_dict_team, onedict, NBA teams, data frame of teams where we are passing the NBA dict, okay, and printing the head for that data frame. Okay, yeah, so we got all of these. We'll use the team's nickname to find the unique ID. We can see the row that contains the Warriors. Contains the word Warriors by using the column nickname as follows. df Warriors equals df_teams. So data frame teams, because this is stored in data. This data frame is df_teams. So within df_teams, we are going to look at df_teams, where nickname equals Warriors, where the key nickname for in the data frame this equals the value Warriors, and we'll store that in df_Warriors. We can use the following lines. Okay, and here we go. We got the Golden State Warriors. We can use the following line of code to access the first column of the data frame. ID_Warriors equals in this data frame. So in the df Warriors data frame, we're going to pick ID, and for each ID, we are going to print the values iteratively. The function league game finder will make an API call in its module stats.endpoints. So So from NBA API.stats.endpoint endpoints, import league game finder. The parameter team underscore ID underscore nullable is the unique ID for the Warriors. Under the hood, the NBA API is making a HTTP request. The information is provided. The information requested is provided and transmitted via the HTTP response. This is assigned to the object game finder. Since HTTP so stats.nba.com does not allow API calls from cloud IPs, and Cloud Skills Network Lab uses a cloud IP. The following command is commented out. You could run it on Jupyter Labs on your own computer. That sucks. Let's see. Let's try. Yeah, I think not. We can see the JSON file by running the following line of code. I don't think so. The GameFinder object has a method get underscore data underscore frames that returns a data frame. If we view the data frame, we can see it contains information about all the games the Warriors played. The plus underscore minus column contains information on the score. If the value is negative, the Warriors lost by that many points. If the value is positive, the Warriors won by that many points. The column matchup has the team the Warriors were playing. GSW stands for Golden State Warriors, and TOR means Toronto Raptors. Versus signifies it was a home game, and at symbol means an away game. We can download the data frame from the API call for Golden State and run the rest like a video. So let's use the import requests. So we're going to import the request library, grab the file name, which is over here as a pickle file, and there it's downloaded. We're going to define a function called download where we're passing a URL and a file name. Response equals request.get URL if response.status underscore code is equals 200. Then with so we use the open method to open the file name, and in the WB I think write and something else I'm forgetting right now. If somebody remembers, please comment and remind us all with a timestamp perhaps. So with the file name that we've just passed open as f, we write in that the response.content. So whatever we got in here, we write in within that, and then we download the file name called goldenstate.pickle. So now we are going to create a variable called file name and store the pickle file in that, and we're going to say games equals pd.readpickle and file name games.head. So here we see all the games where Golden State Warriors fought or who they were matched up against, and the first 5 rows of that. We can create 2 data frames, one for the games that the Warriors faced the Raptors at home, and second for away games. So what we're going to do is games underscore home, where it was a matchup. So we're going to try and find in the game's data frame, we're going to try and find in the matchup column within the data frame with the values where it's equal to GSW versus TOR, because this is a home game for the GSW Golden State Warriors, and this is for the away game, which is matchup, and we're going to try and find GSW at TOR. We can calculate the mean for the column plus minus for the data frames games underscore home and games underscore away. Let's see what the mean is for both. We can plot the plus minus column for the data frames games home and games away. We see the Warriors play better at home than at away games. So away games is slightly worse off than their performance in um, games at home. So calculate the mean for the column PTS for the data frame games underscore home and games underscore away. This would not be possible because, or would this be possible? I think it would be possible. Yep. Yes, it is possible. Okay, so calculate the mean for the column. Means for the column PTS for data frames, games home and games. Okay, okay, I can do that. So what we'll do is games home PTS mean. Right, yeah, I think so, because this is, we are going to try and find the points. Yeah, we're going to try and find the points for and away PTS mean, and let's see, PTS mean, give away PTS mean. Yep, so we got it. And with that, let's save this and move on to the next one. Oh yeah, we were on introduction to API, not on GDP data extraction. We're now going to GDP data extraction. Okay, so now this is the next part, which is GDP data extraction and processing. So in this practice project, our skills will be okay. What is the scenario? International firm. So the project scenario is that an international firm that is looking to expand its business in different countries across the world has recruited you. You have been hired as a junior data engineer and are tasked with creating a script that can extract the list of the top 10 largest economies in the world in descending order of their GDPs in billion USDs, rounded to two decimal places, as logged by the IMF. The required data seems to be available on this URL. After completing this lab, we'll be able to use web scraping to extract required information from a website, use Pandas to load and process the tabular data as a data frame, use Numpy to manipulate and the information contained in the data frame, and load the data frame to a CSV. For this lab, we'll be using the Pandas and Numpy library, Pandas for managing data, Numpy for mathematical operations. So let's start with importing the required libraries, and ideally we do that in one place before we start our execution of our code. So importing NumPy as NP and Pandas as PD. You can also use this section to suppress warnings generated by your code. Define warns, arcs, squares, pass, import warnings, warn.1, warn, filter warnings, ignore. Okay. Okay, let's start with exercise 1. Extract the required GDP from the given URL using web scraping. So this is our URL. We can use the Pandas library to extract the required table directly as a data frame. Note the required table is the third one on the website as shown in the image below. So extract table from web page using Pandas. Retain table number 3 as required data frame. Replace the column headers with the column numbers. Retain the columns with the index 0 and 2. Wasari jattane. Okay, retain the columns with index So first we are going to extract the tables from the web page using Pandas. The tables equals pd dot read dot h read underscore html, and we're going to pass the URL to the HTML. Then we are going to take the data frame, create a data frame variable, and pass the tables with the index 3. Then replace the column headers with column numbers. So we are going to say df.columns equals range. Let's print this df. Okay, so we see the df. Yeah, but next, retain columns with index 0 and 2. Index 0 and 2, which is country and forecast, I think, right? Country and forecast value of GDP quoted by 0, 1, 2. Yeah, this is the value quoted by forecasted value by IMF. So we're gonna say df equals df 0, 2, and then retain the rows with index 1 to 10, indicating the top 10 economies. So df equals df dot ilog, and we're going to try to get 1 to 11, or essentially 1 to 10, because it doesn't contain 11 at a step of 1 each. So then we're going to assign the column names as country name. Df dot columns equals country, comma, GDP in million USD. So here we go. We have the table with country and GDP in millions, top 10 economies of the world in million USD. So, exercise 2, modify the GDP data, GDP column of the data frame, converting the value available in million USD to billion USD using the round method of Numpy library to round the value to 2 decimal places. Modify the header of the data frame to GDP billion USD. So for this, we would say start with the data frame where GDP in million equals data frame where we're going to convert this to GDP in million USD as type, and then we are going to do df where GDP So we're gonna use the numpy round function to a method rather to round each value in this to 2, and then we want to rename uh, one, two, three, four, five. I'm gonna try and see what I can do to fix this. already imported, but you know what? What I'm going to do is I'm going to okay, now let's try and run this. No, still error. What is the invalid syntax? I think it's because this is two. This should only be one. I think that's the mistake. GTP. What? What's going on here? Yeah, this makes sense. Why is it not letting me execute on this? Still the same problem. Yeah. So what's the problem? I'm in this data frame. This is the data frame I'm choosing. GDP million USD data frame. Is this two? Still the same fucking error. I don't understand why. So even with the yeah. DF